Okay, so the idea now is to talk about one page table level or one level page table versus multi-level page table. And in order to understand the multi-level page table, I will do a two-level page table. So page table takes my virtual address and get me to the physical memory. So in single level page table, I have a page table. I take the address, I have an offset and a page. I take the page, go to the page table, and from here, from the page I have, I get to the frame, which is in the physical memory, and return the frame. Now, this is a single, you see there is only a single page. If we look at it, if I have this virtual address, I take page 2, takes me to frame 9. Frame 9 is this, and I get the physical address, which is the frame, and note that this is the offset. This is a single level page table, very simple, very straightforward. A page table using the virtual address, using page, taking the page from this, getting the frame, add to the offset, and getting the frame that I need, the physical address. Now, in two-level page table, and you can conclude from it what happens in a multi-level page table, we have two levels in two-level page table. You have two levels of pages. And in the virtual address, we are dividing it into P1 and P2. Usually it's just half in the size. I mean, if this is, for example, 4 bits, so this is 2 bits and this is 2 bits, and from this to the power of 2 is give me 4, and I have 4 of 4 in my L2 page table. This, if you can see, if it's, for example, 3, so I have 2 to the power of 3 and I get 8. And here I divide it to 2. So I have P1, I take it to L1 page table. From here I get to a sub table, which is the L2. I have sub, which is 1, sub, which is 2, sub, which is 3. And from there, I can get to the frame. Let's see how it happens. So I have P1 equals 3, and then P2, it takes me to P2 equals 2. From here, I get to the frame. Now note that I have a lot of P2 equals 2, equals 3, but I need the L2 table 3. So I count table 3. Table 3 is this one, those 4s, and from this I get a frame. Maybe let's take another example. So P1 equals 1, it's table 0. Take table 0. From here, take P2 equals 0, frame 26. Let's see another example. P1 equals 1, so P1 equals 1, table 0. P2 equals 0, frame 17. Maybe another example with more. No, I want another example, but with more pages. Okay, this is nice. So I have P1 equals 1, table 1, 0, 1. Oh, it counts from here, so 0, 1. P2 equals 0. This is what my address says. This is frame 5. Frame 5 is this one. Now taking the frame and combine it with the offset to get my address. Okay, so the idea is that you can see that I have null over here, because if a subspace of the, let's call it inside tables and outside tables, inside table is one of the inside tables, because you know there are 3 right over here. If one is just 0, I don't use it, so I can say x on this, x on what is call it, and I by that, let's say, save in memory. So the multi-level page helped me to save memory because I can just cut off many subtables that I don't use, and by that I can cut in the primary and the secondary and the third and fourth tables, and by that I can save memory and a lot, because if I have a lot of tables, there will be a lot of inside tables that are like deleted like null because I don't use them. And this is how the multi-level page table can save a lot of memory. So this is the idea of two-level page table. I can conclude how a three-level page table works. And P1, table 1 is this, P2 equals 1, here, frame 19, frame 19. You can see how two-page table and single-level page table works, and this is it. This is the idea. Thank you very much. If there are any mistakes or correction, please tell me. This was about single-level versus multi-level page tables, and that's it.